All right, this video, there's not much to say that's not on the screen. So if you ever were wondering how carbon dating works, this is kind of it's simplified down, the basic idea. So carbon dating assumes that the amount of carbon dioxide on Earth today is the same as that we had centuries ago, or thousands of years ago. And it's because the cosmic rays that we get bombarded with, they actually convert nitrogen to a radioactive isotope of carbon, which is called C14. And so the constant bombardment of the cosmic rays basically keeps the ratio of carbon 12, which is the non-radioactive carbon, and it keeps a ratio of C14, the radioactive version of carbon, to the C12, the non-radioactive, about the same, which that ratio, it's not on this part, it's right down here. The ratio is about this much. So it's pretty small, the radioactive carbon that's in the atmosphere. So that's, you know, 0.000000001%, not even percent. Anyway, it's very small. So, um, anyway, going back to carbon dating. So we have that constant ratio in the air. So what happens is that vegetation absorbs the carbon dioxide through the atmosphere, and then animal life through food chains and stuff also absorbs the carbon the carbon that's in the atmosphere. And so in the living organisms, then we have about the same amount of C14, or the ratio, the same ratio, while the organism is alive. And when the organism dies, it stops absorbing the carbon for or the carbon that's in the atmosphere. And so the C14 that it has inside starts to decay and becomes smaller and smaller and smaller, the percent. And by measuring the ratio, then we can get an idea of um, how old something is. And the idea, my understanding is that we can use this to date non-biological organisms as well, because there's living stuff on things. Like we can still look at the amount of the ratio of C14 in it. So some key numbers when you're doing these problems. It might come in handy to know the half-life of C14. It's about 5,730 years. From that, you can calculate K. Remember that uh, the half-life time is going to be the natural log of 2 over uh, over K. And so you can, actually, let me write that formula down. So the half-life time is the natural log of 2 over K. So you can solve for K and say that K is this. So when you're plugging into formulas, if you know the half-life of something, you can use this to find K. So this is useful to know. And knowing the ratio, you might need to know this as well. So that's pretty much all there is to say about carbon dating.